Welcome back to Hoffman Tactical. So you haven't heard from me in a little bit of time, and it's because I've been working on some not Hoffman Tactical related projects, so I haven't had a lot of stuff to make content on that I thought you guys would be interested in seeing. But it's been long enough, I thought you deserved an update, so in today's video I'll show you one of the projects I have been working on. So we'll step outside and take a look at that. Here we have a basket, which you guys may recognize. We have an old hose. So this is kind of cool. Some of you may know what this is for. Actually, I've had this for some time, and haven't had a chance to use it yet because other parts of the project have required work. But yeah, there's a quick view of that. All right, so here is the place itself. We'll step inside. So some of the very long-term viewers will recognize this area. Over here, this scene right there was featured in a video a long time ago. So if you recognize that, you've been here for a while. That video is no longer on YouTube, so most of you probably never seen it. Okay, so this is the actual area here. If you haven't guessed already, I am building a hot air balloon. That is the big project. So this is the cutting table right here. It's actually kind of a cool table. If we look underneath, you see it's got these kind of cool slanted legs on it. They come inside, they toe in so you don't stub your toes. We've actually got a number of 3D printed parts on it, actually printed in ABS. I got some little wedges there. I got some wedges up in there. You can see them used to kind of space those legs at the proper angle and prevent the need for complex dicey cuts on those 2x4s. So a hot air balloon is probably kind of strange to some of you guys, but those of you who have tuned into some of the live streams and the inadvertent airship discussions we've had might understand a little bit better my interest in lighter than air and hence ballooning. It's kind of the first step into lighter than air. It's kind of the most accessible option. So this is actually like the biggest non-Hoffman Tactical project I've started since starting Hoffman Tactical, and it's been like 4.5 years. So it's been a bit distracting doing a project this large, so that's why you probably haven't seen anything from me. I've been pretty active over on Instagram, and I put some stuff on Twitter still, but design-wise, I haven't really done that much since back in February when I released the SL9. So hopefully once I get this done, I'll be able to get back at producing some stuff for you guys. I'm hoping to get this done in the next month, and then of course I have to finish up flight training, because it does require a pilot's license to fly, like just same as a fixed wing pretty much, and there's some other things I gotta figure out. But I'm finally getting near completion, which is super exciting and should free up some of my time for more of the stuff you're probably interested in. So basically, the way hot air balloons work is you got a bunch of gores. Well, most balloons work this way. We have a bunch of gores. So if you look at this, you can see these gores are kind of like the wedge of like if you're cutting an orange up, the skin of that wedge of the orange. That's those gores that get sewn together. Each gore is made up of little tiny individual, actually pretty big, but on the paper tiny, these little panels. All these panels run this way. So basically the way it works is you cut all those panels out, like 196 of them, and that is what this table is for. So it's the table's got a cork top on it so I can put pins into it. So we've got plywood with cork there along the edge, and more 3D printed parts than here actually. So the fabric roll sits on these little guys down here. They basically just a piece of PVC pipe on the inside, empty fabric roll right there. It can slide up and down as the roll gets bigger and smaller, and the fabric gets pulled out onto this table, 12 layers deep, which is the number of gores. So there's 12 identical shaped panels of each type of panel. I think there's 16 panel types. So they all get pulled out here, pinned down, a pattern gets dropped on top of them, and they get cut out. We then use the sewing machine right here to big industrial sewing machine. Pretty cool, actually. If you do sewing and you're still using a home machine, like they're actually not expensive to get a single needle one. I think they're like $1,200 or something to get a single needle one new, and a lot cheaper if you look around a bit for used ones. So much nicer than one of the light duty machines, I will have to say. But yeah, and of course this sewing machine has this awesome, huge, like 1 horsepower servo motor drive underneath it, which is pretty cool, I will say. But yeah, so we use the sewing machine to sew everything together I've been working on a seam folder design. So this is a 3D printed seam folder, and it works quite well. I've been slowly developing that for it's a lap seam basically, or a French fell seam, where it kind of locks together onto itself. So we sew all of those panels into gores. The gores get stuffed into these trash bags. There used to be 12 of them here. We're now actually down to 5, which is exciting. So they all sit in these trash bags right here. So that is 1 gore of a balloon right there, and then we move on to the next step, which is what's happening down here again, walking back and forth, which is actually sewing those gores into a finished balloon. So that's what I've been working on, and we have this tape holder right here. I think we have an orca back in the corner there, if you can see that. We have this 3D printed tape holder right here, bolts onto the back of the machine, has a bit of tension on it so it doesn't free spin. Tape pulls off of there, comes down here and gets fed on top of the seam as we sew it, and the finished result looks a bit like this right here. So we have the seam underneath. We flip it over, we can see the seam. Let's see, where's that seam? There it is. So you can see we've got, that's the bottom of the seam right there. You can see the double row of stitching because it's a 2-needle sewing machine. And there are the load tape tails ready to be sewn over into a loop at the bottom for the suspension lines to attach to. So yeah, let's see, yeah, here is one of the cool little 3D printed part. And this is actually a tape foot. So rather than buying a commercial tape foot, the way this works is it basically pops onto the sewing foot like that, and it acts as a guide for the load tape as you sew, and it works actually really well. So quite a few little 3D printing gizmos. This is a different seam folder right there that I use when sewing the vertical gores, because you need a bigger gap in the seam folder so that it'll fit the existing seams, the perpendicular panel seams through. Here we have the load tape. So this is vertical load tape. It's webbing, nylon webbing, like 1,000-pound rated nylon webbing, and a couple different sizes here, both 1-inch wide, but this is lightweight. This is a bit heavier. That's for different reinforcements, including the one I just showed you. Here we have some rope, just came in today actually. It's for the crown line, which attaches to the top of the balloon, helps stabilize it as it goes up. Here we have the parachute line. This is a Kevlar core. It's actually the Kevlar fiber tree woven into it, but it's a Kevlar polyester composite line. So the polyester should protect the Kevlar. That is for the parachute, which is the big vent on top. And then this stuff's kind of cool. I don't know how this well is going to work out. This is Kevlar cord, basically polyester covered line I'm going to use for the parachute valve at the top to keep it centered. That's the valve that this thing's pulling. And Kevlar is not honestly the best material for a lot of stuff, so this stuff might, I don't know. We're going to find out how well that stuff holds up and works. It's got a huge safety factor, so I don't think failure is going to be a problem at the knots or anything, but we'll see. That could be interesting. Here we have the thread, and we got, this is polyester for the bobbin. This is for the inside needle of the sewing machine. It is polyester left-hand twist thread, which is standard. And then this big roll here is something I've gotten more recently. This is actually nylon thread, and the reason it's nylon is because it's the only V69 thread I can find that has a right-hand twist to it. So basically the outside needle on the sewing machine spins the thread a different direction, so it needs a different twist, the opposite twist, otherwise the thread unravels. And yeah, so that was kind of a problem I had, which is not a huge problem with now because of the thread, but it's a different color and a different material, which is interesting tension-wise. It takes a bit of adjustment to get it to work. And of course, if you haven't already noticed, there are huge, huge piles of fabric. Lots and lots and lots of fabric. I got like 700-800 yards of fabric, a lot of fabric, and it's finally coming together into something other than just big piles. But for now, that's all it looks like, massive heap of fabric, and it's becoming quite a bit to manage. This is the bag of scraps, so it's like an entire trash bag filled with scraps. It weighs quite a bit. It's like 30 pounds of scraps here. And it's mostly just the strips from cutting the fabric, just little thin strips from the edge. And of course some Nomex scraps as well right there. That stuff was hard to find. Well, that is your quick update from Hoffman Tactical. That's what I've been working on. So building a hot air balloon, pretty cool project. I'll be sure to update you guys on it when it's actually flying, and then yeah, we'll get back to some cool stuff as well. Yeah, so thanks for watching, and that'll be all for today's video.